All right. So today we are going to see factoring and how can we solve fourth degree equations using the technique of factoring. Now again, the main idea here is that we can use the technique of factoring to solve fourth degree equation. Now, again, factoring is just nothing more than a technique that we use to rewrite equations. We're going to try to rewrite a fourth degree equation into something more simple, and then we're going to solve that simple equation. So notice here that we want to solve the following equation. It's kind of the same equation as we had on the previous video or previous lesson. But here there's a slight difference. Here, notice that the highest exponent is 4. And then it comes to 2. Before, this is what we have seen before. This is what we're used to. This is what we have seen before. If we're going to rewrite this equation into something that you're more familiar with, we would rewrite it this way. We know how to factor this. This was explained in the previous lesson. But now, we need to tweak our factoring technique so that it kind of fits this equation. But still, we can still use factoring in this case. So forget about the exponents for a second here. We are going to treat this equation as if it was written into a simple quadratic equation here. So let's see. Let's actually apply the technique that we have seen before. So just again, treat it like if it was written this way. So we still want to have that combination. So we want two numbers that if you multiply gives you something, and if you add them up gives you something else. So here the multiplication, it will be 10. And here the addition, it will be 7. All right, so let's try to find the combination for those two. It might be a little bit straightforward. You can see that 5 and 2 will give you that. Well, multiply, just to be sure. 5 times 2 is 10. That's good. 5 plus 2 is 7. So that's perfect. So now, this is where the difference comes in. If it would have been written this way, then we can rewrite it as x plus 5, x plus 2 equal to 0, just like it was explained on the previous video. If our problem would have been written this way, then we could have factored out this way. But notice that our problem, it's a little bit different here. Our problem, it's this. We have x to the fourth and x to the second. So if this is the case, if you have x to the fourth and x to the second, we, instead of writing x plus 5, we're going to write x squared plus 5. And instead of writing x plus 2, we're going to write x squared plus 2. So if our problem would have been written this way, then we just write it just like we have seen before. But because our problem is to the fourth, all we got to change is just, we got to raise it to the second. Now, if we want to make sure this is correct, if you decide to FOIL this, you would obtain x to the 4 plus 7x squared plus 10. Okay, so right here, what we have is the following. So now we're going to set each expression equal to 0. Okay, sorry about that. So we got x squared plus 5 equal to 0, and x squared plus 2 equal to 0. So now we're going to solve it individually. So now this is a little bit tricky here because we have x to the second. But still, if we want to solve for x, we first need to isolate x to the second. So let's take away 5 here. So now we have x squared equals negative 5. Now, we want to solve, so we want to leave the x by itself. To do that, we need to raise both sides to the square. We take the square root to both sides. So this cancels out. So now we have that x is equal to the square root of -5. But here we're going to encounter a problem because you cannot take the square root of a negative number. So this is not a solution. Or, to be more, this is not a real solution. This is not a real solution because you cannot take the square root of a negative number. Well, let's check it out right here. So let's see, what is the square root of -5? Non-real answer. So this is not a solution because at least right now we're looking for real solutions. You will see later on that this can be classified as an imaginary number, but we're not there yet. So for this example, there's no real solution because you're taking the square root of a negative number. And let's just do the same for the other side. So we have x squared equals -2. Again, if you want to cancel out that second exponent, what you have to do here, you gotta take the square root. Now this cancels out. So now we have that x equals to the square root of -2. Same idea. This is the square root of a negative number. So this is not a solution or not a real solution. So unfortunately here, for this example, x to the 4th plus 7x squared plus 10x plus 10 equals 0. There's no real solution here. There's no real solution here. Let's try another example. Let's try example B now. Let me just clear this up. Okay, perfect. So we got our space now. Good. And again, this is x to the 4th and x to the 2nd. So we know that we are going to try to factor out this way. It's not just x plus x to the 2nd. And we're going to try to figure out what goes here and here. How do we figure it out? Well, we use the same technique as we did before. We're going to be looking for two numbers that if you multiply, in this case, gives you 24. And if you add them up, in this case, gives you -10. Okay, so this is where you start thinking, well, let's look in here. How about 12? 12 and 2. 12 and 2, if you multiply them, 12 times 2, this is equal to 24. But if you add them up, this is equal to 14. Okay, but at least we got the multiplication. Let's see, can we work something out? So we know exactly that 12 and 2 does not work. So I'm just going to scratch that off. But how about -12 and 2? Well, let's check them out. -12 times 2, this is equals to -24. So nope. We can cancel that right away. So let's try to look for another combination here. How about -6 and -4? Well, let's check them out real quick. -6 times -4. This is equal to +24, so that works. -6 plus -4. This is equal to -10. Perfect. So -6 and -4 works out. So if it's x to the 4th and x to the 2nd, we don't write x, but we write x squared. And what goes here is -6. And what goes here is -4. All right, perfect. So now that we have a combination, we just rewrote our problem. And now if you have two expressions which are multiplied equal to 0, so you can set each one of them equal to 0. Oops. So x squared minus 6 equals 0. That's our first equation. And x squared minus 4 equals 0. That's the second equation here. All right, perfect. So let's solve for this. Plus 6. So now we have x squared equals to 6. And again, you want to solve, so you want to let this x equals by itself. So to cancel that second exponent, you take the square root of both sides. This is good, cancels out. So now we have x equals to the square root of 6, which it's not a perfect square, so we're just going to leave it as that. So this is a solution. So now in here, let's solve for x. So cancels out. So we have x squared equals to 4. Again, you want to cancel out the second exponent. So we take the square. Take the square, cancels out. So here, we know that the square root of 4 is 2. Let me convince you. Go to your calculator. The square root of 4, it is equal to 2. So you might just say that, well, my answer is just 2. But notice that here, when you're solving for a variable, if your last step is to take the square root, you have a plus or minus 2. You have a plus or minus 2 here. So we have two solutions here. And again, if you're solving for a variable and your last step is to take the square root, and that's a perfect number, so we have plus or minus 2. So here are your solutions now. Your solution is when x is equal to the square root of 6, because that's the first solution that we have here. When x equals to the positive of it, which is 2, and when x is equal to the negative of it, which is negative 2. So notice that the process becomes a little more tedious when we have an x to the fourth, but it is still doable. We can still use the same technique as factoring. Now, our last example here, notice that we don't have the same setup as the x to the fourth and x to the second, but notice that this problem, it's exactly the same as the first problem, but it's just a little bit different, if that makes sense. Because notice that in here, every single term has an x. So what we can do in examples of this form, if you notice that they have a like term, which in this case is x, we can factor out that term. So if we factor out an x, what we're going to obtain here is x to the fourth plus x to the second plus 10 equal to 0. But notice that this is exactly as the first problem that we have. Notice x to the 4 plus 7x squared plus 10, x to the 4 plus 7x plus 10. So what we can do here is that we can factor it out, which we already saw on the first example, that x to the 4 plus 7x plus 10, you can factor this out as x squared plus 5, just regular 5, and x squared plus 2. We already saw this on the first video, on the first problem here. So notice that now you have three expressions here, x squared plus 5, and x squared plus 2. They're still all multiplying, and they're all equal to 0. So what we can do, we can get each one of them equal to 0. So I'm going to get the first multiple, which is x, and I'm going to set it equal to 0. I'm going to get the second multiple, and I'm going to set it equal to 0. And I'm going to get the third multiple, and I'm going to set it equal to 0. All right, so at least notice that here, this is already solved. We have one solution right away, right here. x equals to 0. There's nothing we can do. X is already solved, so that's it. Let's solve for this. Take away 5. X squared equals -5. And again, if you want to cancel out the second exponent, we take the square root. So now this says that x equals to the square root of -5, which we already said that this is no real solution. We said that this is no real solution. Well, let's check the last one here. X squared equals -2. Take the square root. So this cancels out. So now we have that x equals to -2, which again, you're taking the square root of a negative number, so this is not real. So at the end of the day, we only have one solution. X equals 0. Now, here's your entrance ticket. Solve the following function.